Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome back. In this video, you're going to see me factor a lot of polynomials. I'm going to go over some ways to approach each type and then just walk you through a bunch of them. Some of them we're going to be able to do mentally without showing a lot of work. Others we're going to go ahead and have to kind of break it down. I'm going to be using a few methods that you may or may not find in textbooks, and I'll be comparing the two, so make sure you pay close attention for what might help you out better in your classroom. So the first example we're going to get to is we're just going to use some a's and b's. So we got 12a cubed b plus 15ab cubed. So factoring just means, we'll just go ahead and do a side note. If you remember when you were younger, you did prime factorizations. And that's actually what we're after here again. And let's say your number was 30. You would go, well, 30 is 5 times 6, and 6 is 2 times 3. So the prime factorization of 30 is 2 times 3 times 5. And you could have written those different orders, but 2, 3, and 5 are each prime numbers, meaning they have exactly two factors, 1 and itself. So when we have polynomials, meaning we have variables, we have more than one term, that's what we're looking for, is we're looking for prime numbers. And with polynomials, you want to try to have no exponents, especially inside the parentheses. Okay, so that's what our goal is here. So the first step you should always check for is a greatest common factor, and that means something that divides both this and this. So if we look, 12 and 15 are both divisible by 3. Both of these have an A, and both of these have a B. So what we're doing here is we're reversing that distribution process. So what would have to be here so that when we distribute, we get 12? Well, 3 times what is 12? That would be 4. And then we have an AB, but we need A cubed B, which means we would need 2 more A's. Then we have that plus sign. So now we need to do the same for the 15AB cubed. So 3 times what is 15? That would be 5. We have an A and a B. We need AB cubed. So that's why we would have a B squared. And I will get into later why this is now a prime polynomial inside here, or a prime factor. But we have pulling out the GCF, and you always, 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 first step in factoring is you check for a GCF. This will make your life a lot easier whenever you're working on problems with really big numbers. So let's just check a few more, practice a few more GCFs just to make sure you've got the process down. Our next example, and I know I'm kind of, letting you know ahead of time, it's going to have a greatest common factor. 24x squared minus 8x. Let that focus. So now we want to think of what's the greatest common thing that 24 and 8 both divide by. And they both have a greatest common factor of 8. If you're ever curious about that and you're having trouble thinking about it, one thing you can do is you can make I usually do the smaller number on top and the bigger number on bottom. And I can see that 8 over 24 reduced to 1 over 3. And I just have to think, oh, what divides both of these to make both of those? And that would be 8. So you can actually use fractions to kind of help you out. Because they both have a variable x, they also have that as part of their GCF. And then we're ready to reverse that distribution process. Remember, this is the answer to a distribution problem, and we're just going backwards. That's all factoring is reversing that multiplying process. So 8 times what is 24? And if you said this is 8 times 3 and this is 8 times 1, you'd be correct. So we'll have a 3. It was an x squared, but we have an x out front, so we'll have an x in here. Minus. Now you might notice that this is 8x and this is 8x. And some students are content to go ahead and just write this. And they stop. This is bad. Because when you multiply this, you only get the 24x squared, where this was a binomial, meaning it had 2 terms. So since there are 2 terms, when I pull out the GCF, I need 2 terms. So make sure you know that when utilizing a GCF, it doesn't change the number of terms in your parenthesis. And again, we can see here that this is 8 times 1. So I have to have at least a 1 there. And then we can see that the x is already taken care of, so this will be a true statement now. Wonderful thing here is we see that we have no exponents. That actually is our goal, is trying to have no exponents, especially inside the parenthesis. So this is the last strictly GCF problem we're going to be looking at. So let's think about that. What is the GCF this time? If you said 5xy, you'd be correct. 5 times 2 is 10. This is xxy. I'm going to write that down, xxy. We move this out front, meaning it still has that x. And if you need to write it down that way, that's perfectly okay. So I'll go ahead and I'll write 15 as 3 times 5 times x times y times y. And we're pulling the 5, the x, and the y out front, leaving us with 3y. Reminds me of a cool trick I wanted to show you. Okay, if you do Venn diagrams, some of you might be familiar with Venn diagrams. And you think of the 10 as 2 times 5 times x times y. And you think of the 15 part as 3 times 5 times x times y times y. Then you can see this right here, how the 5 goes in the middle. Should do that in a different color, shouldn't it? Yeah. There we go. An x in common, a y in common. And then we have a 2x left in this circle, and we have a 3y left in that circle. So if you're really good at Venn diagrams, then this is really going to help you, because now we can see the 5xy went out front, the 2x was here, and the 3y was here. So for some people who are visual learners, that Venn diagram is going to really help you out. Otherwise, I actually find it more cumbersome in this case. I do have a great way of using this for, we saw that this is the greatest common factor. If you multiply everything together, you get the least common multiple, which is kind of a cool trick that I utilize later on. Okay. So before I move on to problems that do not have a GCF, I want to go back and I want to discuss how multiplying binomials works. So some of you might have forgotten, and that's okay. Every time, once in a while, we forget things. I've been doing this for a long time, so if I've forgotten something, it's probably not about math. Okay, so many people are not comfortable with multiplying this. A lot of times in schools, you'll hear the acronym FOIL. And FOIL works great when it's a binomial times a binomial, meaning there's 2 of each. But when the quantities get bigger, the FOIL acronym kind of fails us. So because of that, I use a box. Okay? Now we're going to go back even further so I can explain my box. In elementary school, you might have used an area model to help you visualize multiplying. So not everyone can do 14 times 13 in their head. And in elementary, that was kind of the goal of teaching the box method, was so that you could do mental math. It wasn't for replacing the algorithm for multiplying that I had when I was a kid. So we're going to think about this as a 14 by 13 room that we're trying to find out the size of, but we're trying to do it mentally. So we know 14 is 10 plus 4, and we know 13 is 10 plus 3. And instead of thinking it as one big room, we're going to think of it as 4 small rooms. Again, this is just so we can do mental math. So a 10 by 10 room is 100. Most of us can do 10 by 10 in our head. A 10 by 4 room is 40. A 3 by 10 room is 30. And a 3 by 4 room is 12. And now I can add that because 30 plus 40 is 70. 70 plus 12 is 82 plus the 100. That's 182. The entire reason behind learning that was so that you had pure mental math. You didn't have to worry about putting down a number and carrying a 1 or lining up columns. It was just a way to help you visualize it. If you're really good at visualizing in your head, you're probably really good at doing multiplying problems in your head. So how can I use this same grid method, the area model, to multiply this x plus 3 times x minus 8? Well, I'm going to draw the same grid. I call it a box. Kind of looks like a Punnett square sometimes if you think about it. And actually that idea is what we're using, is the Punnett square. So the dimensions of our quote-unquote room are x plus 3 times x minus 8. And just like with all multiplying problems, the multiplying order doesn't matter, so you get to pick where you put it. So this first box has the x and the x being multiplied together, just like that 10 and 10, so x by x. The second box has the x being multiplied by the 3. This box has the negative 8 being multiplied by the x. And this box has the negative 8 times the positive 3. And I wrote those in pencil. We're going to come back now and write the answers. Xx is easier as x squared. X times 3 is positive 3x, negative 8x, and negative 24. And now we're going to put those orange things together. If you'll notice, these happen to be like terms. And we're going to wind up with an answer of x squared, negative 8 plus 3. Think if you owe $8 and you have $3, what's your balance? Negative 5. And if you have trouble with combining like terms, I think of it as you owe 8 xylophones to your customer. You only have 3 xylophones. What's your balance? You're in the hole, 5 xylophones. Okay? And then I think of the x squared as somebody who ordered 2 xylophones instead of a single, a square xylophone instead of a normal xylophone. Just make sure it sounds like something different in your head if you need help visualizing. So in our next problems, we are going to be starting with this and going back to that. Now, if you'll notice, the FOIL acronym, this would have been our first, this would have been our outside, this would have been our inside, and this would have been our last. So the FOIL acronym is still holding in there. But the big thing that you need to remember is this comes from the first terms, the x and the x. They were the first of each of the parentheses. This comes from the last because 3 times negative 8 is negative 24. This here in the middle is the outside and the inside sandwiched together. So they've smashed them together and made them one. So we have to be careful with that. So I'm going to start off with one that we're going to do mentally. Okay. If you can do FOIL mentally, then you will be much faster. Sorry, not FOIL, factor. If you can do factor mentally, you will be much faster at these. And this factoring process really has a lot of applications in math, especially going all the way through calculus. So factoring is going to be a very big help. The faster you can do this, the easier your algebra career is. So we know that we're trying to, first of all, there's no GCF, nothing in common between the 3 terms. So we're going to try to go back to a multiply problem. Because the first thing is x squared, the only way to get x squared is doing x times x. The last part is a positive 2. There are only two ways to multiply to positive 2, and that would be positive 2 times positive 1. I know you're thinking two ways. Or negative 2 times negative 1. However, all the signs in the problem are positive, meaning we're only going to use positives. So positive 2 and positive 1. Now I'm going to check. I'm going to use that FOIL acronym this time. First, x times x. Outside, x times 1. See how it's like distributing? FOIL is really just double distribution because I distributed the x, now I'm going to distribute the 2. That would be our inside. And 2 times 1 is 2. And when I combine these in the middle, it did work. This is what's known as a guess and check method. Don't just guess. One other way that can help you is if you graph it on Desmos. If it crosses at simple numbers, it's going to factor, and those numbers will play a role in our factoring. So we can actually see that that is at -1, and that is at -2. Okay, so it crossed the x-axis at -1 and -2. And if we look here, -1 plus 1 is 0. -2 plus 2 is 0. So there is a relationship between the graph and the factors. And that is very helpful if you ever get stuck factoring, that you can actually go back and check the graph. Now, a key point to know. When using a graph for help, if it does not cross the x-axis, it is prime. Okay? And I'm going to add a caveat to that because I know the Algebra 2 EOC in Missouri has us do some stuff with some extra factoring. This is prime using real numbers. The Algebra 2 EOC does have us doing some factoring with imaginary numbers. For the purpose of this video, I will point that out. However, for a lot of places when you're working with mathematics and stuff and you're trying to solve equations, we only need prime factorizations in the real world, not the complex world. So I will point out the problems that Missouri would expect you to come up with for the complex world. Okay. So here we see it's quadratic because it has an exponent of 2, but it's a binomial where our last problem was a monomial, or sorry, a trinomial. The last one was a trinomial. Ooh. This one is only a binomial because they skipped over that linear term, which means that when we think about that grid, I'm going to go ahead and draw that box. And remember, this was the first, this was the last, this was the outside and the inside smashed together. So the first thing was x squared, the last thing was -9. But when this and this smashed together, they canceled out. Okay. Well, let's think about that. remember again, we're trying to get binomial times a binomial. And what is the only way to multiply to x squared? Well, we can do x times x, which is good because that's an x squared, x times x. Now this is a negative 9. So in order to get a negative, we need to do a positive times a negative. And again, this is kind of a way of guessing and checking. We're just kind of logically thinking it through. Now we could have a 9 and a 1 here, because negative 1 times positive 9 is negative 9. But that would give us a 9x here and a minus 1x here. And when I combine them together, they don't cancel out. So that was kind of the wrong guess, right? I know there's some people that are really good at this and are screaming at the video right now going, lady, it's this. We could also do positive 3 times negative 3. And positive 3 times x is 3x, and negative 3 times x is negative 3x. And they do, when you add these two sections together, they're additive inverses. They cancel out, they go to 0. So, because this was the area, these are our dimensions, right? That's what this model is doing. It's backing up your elementary model from area. So we have a factor of x plus 3 times a factor of x minus 3. So they're giving us the product, we're giving them the factors. They're giving us the inside of the grid, we're giving them the outside. Okay, reversing that FOIL process. Okay, x squared plus 4. We're going to try to reverse that FOIL process. Remember, our goal is to have this. I'm going to go ahead and draw the grid. Okay, we have an x squared, we have a positive 4. These two boxes cancel out. Okay, so the only way to get x squared is x times x. The only way to multiply it to positive 4, well, we could do 4 times 1, negative 4 times negative 1, 2 times 2, or negative 2 times negative 2. That's it. Okay? But we talked earlier about when everything's positive to use only positive, so that's going to go away, and that's going to go away. Well, if I put a 4 and a 1 here, that makes 4x and 1x. Those don't cancel out and go away because they skip the middle term, so that didn't work. What if I put 2 and 2 here? That would make it 2x and a 2x. Those, if one of them were negative, would be additive inverses, but they're both positive. So when I combine those, they make that 4x. So that's not what we need either. And if I look at this graph, let me turn off that light, it doesn't cross the x-axis. So in the real world, this would be prime. Okay? We cannot technically factor this using real numbers. So this is prime, again, using real numbers. If you're a student who understands what imaginaries are, then you can follow along. If not, you might fast forward through this. So I'm going to adjust the problem for those who work with imaginaries to x squared plus negative 4 times negative 1, or x squared minus 4 times negative 1, same thing. Negative 1 is going to be a placeholder for my I squared, because that's what negative 1 equals, is negative I squared. Now we can go ahead and look at this as put the x squared here and then minus 4i squared. And we know that for things to cancel out, they have to be the same number, one positive, one negative. So I'm going to make this x and this x. Negative 4 is negative 2 times positive 2, and we'll need the I. And this would make negative 2ix, and this would be positive 2ix. Therefore, they do cancel. And we have our factors of x plus 2i times x minus 2i. All right, so these actually bring up what's known as a rule. We have two rules. We have the difference of two squares. And we have the sum of two squares. Okay. Anytime you're giving the difference of two squares, a squared minus b squared, it's going to factor into a special pattern that we actually just did of a plus b, a minus b. And we saw that when we did the x squared minus 9 problem. Now I know you might be thinking 9 isn't written as something squared. Well, if you think of it as x squared minus 3 squared, now it is, and our answer was x plus 3, x minus 3. This is a rule that I suggest you memorize and you become comfortable with because you're going to use it a lot. The sum of two squares, I'm going to use x squared plus y squared, is technically prime. Okay. However, you can change this to x squared minus I squared y squared. And then it becomes a difference of two squares. And now that's x minus iy, x plus iy, if you're working in complex numbers. So keep that in mind. A sum of two squares can be changed to a difference of two squares by using complex numbers and then going back. So I'm just going to practice some different difference of two squares. Okay. So x squared minus 25. Okay, that's x squared and 5 squared, so it would be x plus 5, x minus 5, just by using that rule. And again, the exponents are gone. Now, 25 minus x squared. See how the order changed? So it's not really going to make a difference on the plus one, but it will make a difference on the minus one. So it's important to make sure you do that. 5 plus x, 5 minus x. So make sure a comes before b, especially on the subtracting side. What about negative x squared plus 16? This looks like it's not a difference of two squares, but I can add in either order. So the first thing I'm going to do is I'm going to make this and do 4 minus x, 4 plus x. Or, I'm going to GCF out a negative 1 and make that negative. So double check, negative 1 times x squared, yep. Negative 1 times negative 16, yep. And now that gives us okay, so the big key here is that this times this gives you that. And that actually can be a really good advantage point when you come to factoring and problems that are more complicated, when factoring is not your actual goal, it's just a step you do. So keep in mind, a GCF of negative 1 can always be a quick lifesaver. Okay. What about if they have a coefficient? Okay, this doesn't look like a difference of two squares, and you're correct, it's currently not. However, it has a GCF of 2. If you remember, I talked about always doing the GCF first. And now this part is a difference of two squares. And for that part, we'll have the 2 out front, right? And now this breaks down into that x plus 2, x minus 2 pattern. That's just like taking that 30 and making it 5 times 6, but then we had to change that 6 to 2 times 3. So remember, we're going for a prime factorization. Always check for a GCF first. And 4x squared minus 1. Now the number in front's bigger than the number at the end. That's okay. Everything is a perfect square here. 4 is 2 times 2. And then negative 1 is 1 times 1. So it was also a difference of 2 squares. So one of my favorite patterns, you'll use it a lot, difference of 2 squares. Speaking of difference of 2 squares, we're going to do a complicated one now. This is still, let's say A equals x plus 4 and B equals x plus 1. So I'm going to replace the x plus 4 with A, and I'm going to replace the x plus 1 with B. So it is an a squared minus b squared pattern. So it should factor to a plus b and a minus b. Okay. So a is the x plus 4. And yes, I put that in parentheses. Oh, a 4 kind of looks weird. There we go. And b is the x plus 1. Okay. And now we do want to simplify what's in there. So x plus 4 plus x plus 1 would be 2x plus 5. And you have to be careful here to distribute that negative. So we really have x plus 4 minus x minus 1. And that simplifies to just a plain old 3. Okay. Now, a lot of you are not going to approach the problem like that, so we're going to do this with a separate method, and I'm going to rewrite this pretty. We came up with this as a factor. How this complicated thing, just go to that. So many of you are going to x plus 4 squared minus x plus 1 squared. We have to multiply. X squared plus 4x plus 4x plus 16. Let me slide that up. Some of you might have just wrote x squared plus 16, but then you would have done that meme of, hurting the puppies, and we all want to save the puppies, so don't make that mistake. Okay, I did that one in orange. I'll do the other one in light blue. So we have x squared plus 1x plus 1x plus 1. Okay, so we have this minus that. And because I like to show things differently at different times, I'm going to actually do a vertical subtraction. X squared plus 8x plus 16 minus, notice how I wrote that very far out front, x squared plus 2x plus 1. Okay, so we're doing a subtraction problem. So we're just going to focus on each part at a time. So the first thing we're going to look at is x squared minus x squared. And 1 minus 1 is 0, so that cancels out. 8x, 2x, and we're subtracting. So 6x, and 16 and 1, and we're subtracting, and that would make a positive 15. So the original problem of x plus 4 quantity squared minus x plus 1 quantity squared just simplified to 6x plus 15. Now we can see it has a GCF of 3. And when I take out the 3, 3 times 2 makes 6, and the x, and then 3 times 5 is 15. So that's the same answer as we got before, we just approached it differently. So this time expanding it out made the factoring very simple. Sometimes expanding it out makes it more complicated, so you might be careful with doing that. So we were able to do that problem using 2 different approaches. Okay, so now that we've looked at several of the binomials, let's look at what happens with trinomials, and let's just go ahead and try a few of those. And I'm going to keep it simple in this video. My a value is going to stay 1, or will be the GCF. So let's look at x squared plus 6x plus 8. We know we're trying to get to this. Okay. And I'm going to be teaching the guess and check method first. We know this is our first, and we know this is our last, and we know this is the outside and inside put together. So x squared is pretty straightforward. It has to be x times x. Everything's positive, so I'm not going to worry about negatives. 8 is either 1 times 8 or 2 times 4. But we need the outside and the inside to make 6. So would we choose 1 and 8 or 2 and 4? And if you said 2 and 4, you were correct. And that is our factor. Okay, you may not like that. You may not like that at all. Okay, so for you, if you're one of those people who are like, cannot do that in my head, it's perfectly okay. What we're going to do here is we can put the first in the first box and the last in the last box. And we know the middles have to make 6x. Okay, so then we're just going to test. We know this is x and x. If this were a 1 and this were an 8, we'd have 1x and 8x. 8 plus 1 is not 6. Okay, notice I did that in pencil. Pencil erases, right? So 1 and 8 didn't work. So we're going to try 2 and 4, and 4x and 2x. Absolutely, that makes our 6x. So when it starts with a 1, I highly encourage you to be able to use guess and check. Okay. So here we're going to need to be very careful. Okay. And I'm going to go ahead and start that grid. For those of you who want that, I'm actually going to do the grid method first. If you're practicing guess and check, you might kind of mute this or whatever, and you might try it. Can you just do it off the top of your head? So for those of you who need the grid, remember this is first, this is last, this is outside and inside smashed together. Okay. So we're guaranteed this is x and this is x. But now we're multiplying to a negative 6. Okay. It could be 1 times negative 6. Could be negative 1 times positive 6. It could be 2 times negative 3, or it could be negative 2 times positive 3. Okay, so we're going to kind of think. If this were a 1 and this were a negative 6, this would make 1x and negative 6x. Well, negative 6 plus 1 is negative 5, not positive 5. So that was really close. The only thing wrong with it was the sign. So we're not going to try these numbers as our second guess. What we're going to do is we're going to switch this up and make this positive and this negative, which switches this up. There's our positive 5x, and now we know that it is a positive 6 and a negative 1. For those of you who did guess and check, did you get to the same point? this problem is almost identical. The only difference is instead of a minus 6 at the end, we now have a plus 6. How is that going to change our problem? First, last, outside and inside together. Okay, we definitely have our x and our x, but we got to figure out these others. So pencil comes out, right? The ways to multiply to 6 are 1 times 6 or 2 times 3. So, or -1 times -6 and -2 times -3. But we've talked about if everything is positive in the problem, only use the positive numbers. Okay, so not going to worry about these right now. 1 and 6 gives me 1x plus 6x. That makes 7x. That's not good for us. Okay, so not 1 and 6. So my next guess is going to be 2 and 3. Okay, so that would be 2x and 3x. And 2x plus 3x is definitely 5x. So absolutely it was plus 2 and plus 3. Had we had this problem, what would we have done? Well, this would have made positive 5x. And we need negative 5x, so that's close, right? The difference is it would have been x minus 2, x minus 3. So still multiplying to that positive 6, but this time we had to use negatives because there were negatives in the problem, right? And if you want to check it, first, outside, inside, last. Yep, definitely makes that negative 5x. So 3x squared plus 21xy minus 54y squared. Whew. I thought I didn't, indicate that I was going to have numbers in front of that x squared. I did say that, but I also said, hey, or a GCF. And while it may not look like it right now, 3, 21, and 54 all divide by 3. They make 1, 7, and 18. Okay. So again, always, always, always check for a GCF. Okay. But we still have exponents in here, so we're still going to try to break that down more. So we're going to hopefully have 3 and then 2 parentheses. Now, if you were checking this with Desmos to see if it breaks down more, you can't graph the x, y together. So what you're going to have to do is do x squared plus 7x, and only do the x minus 18. And we'll come over here. Sorry about the light. Yes, it is crossing twice. So it is going to go ahead and break down. More importantly, if you looked at it, it was crossing at 2 very unique numbers. Okay, so let's go ahead and just do the box for this part. The first thing was x squared. The last thing was negative 18y squared. And the middle was 7xy. Don't let the fact that there's extra variables mess with you. It's okay. Now, the only way to get x squared is x times x. And that's what we're focusing on in this video, is where this is always 1x squared. Another video, we're going to focus in on the proper way to do it. So, negative 18. It could be negative 1 and 18, 1 and negative 18. Negative 2 and 9, 2 and negative 9. Negative 3 and 6, 3 and negative 6. And here's another fun thing. The square root of 18 is 4.24. You will never try any number bigger than 4 when you're checking factors. It's just a cool trick. It finds you the middle. If you can find the bottom half of the divisors, your top half will be there. So never try any number bigger than the square root of your number. So 18 does not divide by 4, so we're done. It's going to be one of those 6 choices. Okay, now some of you might have already picked up, hey, which one of these add 7? Well, that adds to 17. That adds to negative 17. Ooh, this one adds to 7. Negative 2 plus 9. So I'm going to do a negative 2 and a positive 9. But 9 times negative 2 is only negative 18, and we need y squared. So I'm going to put a y here and a y here. So 9yx, 9y times x is the same thing as 9xy. Negative 2 times y times x. That's the same thing as negative 2xy. We're just changing the order. And when I take the 9 and I add the negative 2, it comes out to be 7. So there we go. Our factoring is going to include an x plus 9y and an x minus 2y. Okay. So there we go. We have that factoring, and we are going to do one last complicated one, and then that'll be the end of this video. This is kind of like that difference of 2 squares problem where I gave you parentheses that were kind of matching and things like that. So you could go ahead and work this all the way out and simplify it. And I'm going to do that really quickly. X minus x squared minus 2x plus 1 minus 10x plus 10 plus 25. I FOILed and I distributed, so we have x squared minus 12x plus 36. Whew. So I made sure to be very careful with x minus 1 squared. This is where I distributed that negative 10, and then that's just the 25. And then I combine like terms. So now, we're going to do this mentally. What multiplies to 36 but adds to negative 12? That would be x minus 6 and x minus 6, or x minus 6 squared. Focus, come on. You can do it. And that is how fast you probably should be getting to be able to go from here to here, as you should just say, hey, what multiplies to 36 and adds to negative 12? And those of you who are really good at your mental math facts, this will come quicker too. However, if you're afraid you might make that mistake, we're going to go ahead and say P, for parenthesis, is x minus 1. So we had a parenthesis squared minus 10 parenthesis plus 25. Okay, we know this is P times P. We know the 25 is either 1 times 25, negative 1 times negative 25, or 5 times 5, or negative 5 times negative 5. And if we're thinking about the outside and the inside together, the only ones that are going to add to that negative 10 are going to be this. Notice how I kind of did the box, but I did it notating wise instead of actually drawing the grid. Go ahead if you need to, pause this and draw that grid and see that you agree. So remember our parenthesis was x minus 1. And if you do x minus 1 minus 5, you get x minus 6. And you get x minus 6. So same answer, different process. Okay. For those of you who are having more than 3 terms, or who have powers that are not sum of 2 squares, difference of 2 squares, or who are worried about an a value, that video is coming. Stay tuned.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.